Welcome, Theater 5. Is everyone still awake? Still have energy? Let me hear it. Yeah. My name's Anthony Pago. I'm a senior product manager here at AWS. I've been doing a poll. I got to do it for the last one. If this is your first reInvent, raise your hand. All right. Yes. That's great. It is my first reInvent too. I'm super excited to be here, and it's been a great couple days. I'm excited to introduce my colleagues here at AWS who are going to do the last session of the day. Denise Gosnell, who is a principal product manager, and Dave Beckberger, who is a principal graph architect. Come on out.
Hi everyone, how's it? Whoa, sorry. Hi everyone, how's it going? Thank you for coming. I know it's been a long reInvent. I don't know how many miles I've walked, but I'm sure you guys have probably walked a ton as well. So I enjoy sitting down for 20 minutes here while we talk about Amazon Neptune Analytics and some of the new graph analytics and Gen AI capabilities that we just launched yesterday. I'm Dave Beckberger. I have with me Denise Gosnell. I'm a principal graph architect on the Neptune team. She is a principal product manager on the Neptune team. And we're here to talk to you a little bit about what our new release was. So, as many of you probably know, and probably many of you have seen this slide or a very similar one, we support data workloads for your applications with the most complete set of relational and non-relational databases and purpose-built databases such as DynamoDB, DocumentDB, ElastiCache, and in our case, we're going to be talking about Amazon Neptune. What is Amazon Neptune? Amazon Neptune is a fully managed, purpose-built graph database built and managed for the cloud. It's optimized to store and map billions of relationships and enable real-time navigation of these connections with millisecond query response times. It's, as I mentioned, this is part of a really built a way to scale your architecture of your graph data. But what is graph data? Kind of haven't talked about that too much yet. Graph data is data where you deal with the relationships and connections between data, where those relationships and connections between data are as important or more important than the data itself. So when we do that, when we're looking at that, and we look at how this works, Neptune is a great example of how you can use this data and use this data at scale to be able to do this with a pay-as-you-go model. But over the years, we've worked with many customers, and customers have said they've really wanted to make data discoveries faster by analyzing graph data with those graph data that contains tens of billions of connections, and do this in such a way where you're looking at most to all of the graphs. With that, we had yesterday, I don't know if how many of you saw Swami's keynote announcement, we announced a very new product called Amazon Neptune Analytics. And I'm really happy today to have Denise Gosnell up here, the principal product manager, to talk a little bit about what that product is and how you can use it to be successful in your applications.
Thank you. Thanks, everybody, and thank you so much for staying here for one of the last talks of the day. We could not be more thrilled than to be announcing Amazon Neptune Analytics during reInvent this year, which was yesterday, as you just heard from Dave. Now, Amazon Neptune Analytics is a new analytics database engine for working with your graph data in the AWS cloud. It helps data scientists, data engineers, and application developers discover insights about that connected data that you just heard Dave speaking about within seconds. There's three main ways to think about what you can do and what is available in Amazon Neptune Analytics. And the first one I want to talk about is what our early access customers have been most excited about. And that has been that it's a single service for working with graphs at AWS. We're working on making it so much more straightforward for you to work with your graph data and analyze your connected data. So when you're using Amazon Neptune Analytics, you're going to be working with graphs provisioned to a certain capacity instead of having to manage all of the infrastructure in order to actually build and work with your graph analytics. When you're working with your graph data, you use a popular open source query language called OpenCipher. And for those of you who are new to query languages, that query language is much like SQL. And the second thing that our customers have been loving the most so far is how fast the engine is. It's 80 times faster for getting insights from your graph data within the AWS cloud, where we can load about 10 million pieces of graph data into the engine per second. You also are going to be able to analyze billions of edges in seconds when you are using Amazon Neptune Analytics. And it's giving you much faster ways to be able to do those joins, which is why we care about working with graph data. And then lastly, and many reasons why you all might be sitting here today, is that within Amazon Neptune Analytics, there's a vector search engine so that you can combine a vector similarity search with the graph data. And what that does is it makes your similarity searches explainable. It gives you the ability to ask questions like, what is similar to this? But then go through the explicit relationships and tell you why. Give you the context to make it much more explainable and understandable to have higher level conversations and make decisions and actions with your data. I'm going to give you a quick overview of the 3 main types of use cases that our early customers have been building with Amazon Neptune Analytics, and then we're going to dive into a demo. I'm going to show you how to build a graph, and then show you how to work through some graph algorithms, and we're going to do some vector search up here as well. To get started, the most popular way that customers are wanting to use Amazon Neptune Analytics is for their ephemeral graph loads. You can imagine a data science team that might have a one-off process that is building custom infrastructure, running custom code to run an algorithm and then get insights about your data. Amazon Neptune Analytics is a really great way to spin up a graph, load your data very fast. Then you can run algorithms combined with low latency queries and vector search in any combination. It does have durability, so you can write back the results of your algorithms. You can maybe add new edges that you've discovered during your analysis. And then you can take a snapshot of your graph to then do additional analysis and other workflows. The second most popular way that our customers have been using the new graph engine is for doing low latency analytical queries. And that's been most popularly a part of their existing machine learning pipelines. Say you have a machine learning feature table, and you want to add a new column, 2 or n, and in those columns, you want to put an insight that came from your graph. Neptune Analytics is a really great way to load up your data quickly, determine that insight, and then store it in that feature table for use in your established ML pipeline. The third way that our customers are loving using Amazon Neptune Analytics is for doing vector search with graph data. We have an early customer who has been experimenting with how they can reduce the cost of their wet lab experiments by determining candidate drugs that may be relevant for testing in the pharmaceutical industry. What they're able to do is they're able to take their proprietary knowledge graph and do a search of a vector that represents a protein. What that search does, it gives you candidate proteins that might be viable wet lab experiments. But by combining that similarity search and maybe a path discovery traversal, they can determine if it's even worthwhile, giving them a lower total cost for their research in their wet lab experiments. So those are the 3 ways that our customers have been using Amazon Neptune Analytics so far. Before we get back to the thank you, let's do a demo. Okay. Thanks, Dave. All right, so where we are right now, we're just in the AWS Management Console. We're over in Ohio. We have deployed Neptune Analytics to 7 regions around the world. And to find it, we're going to start by going to Neptune. And for those that have, actually, before we get into this, is there anyone here who has used Neptune before? Awesome. Thanks for coming. You'll notice on the left-hand side that we now have a new navigation that takes you down to an analytics section. So from here, we're going to go to graphs. You can see I built a graph just earlier. And I need to grab the S3 location of the data I'm going to load for you, so pardon me one moment.
So Denise, while you're doing that, where can I load my data from here?
That's a great question, Dave. Thank you. So when you spin up a graph here in the moment, you're going to see that you can load your data from 1 of 2 sources. You can load it directly from an existing Neptune cluster, or you can load it directly from S3, which is what we're going to do in this demo, and I had to go grab the URI, so thanks for your patience. So we're going to start by creating a graph, and we're going to give it a unique name. The date is the 30th, and this is the second time I've done this today. We're going to create a graph from an existing source, but today's question that he just asked, you can create an empty graph if you would like, and then you can load the data through an OpenCipher call command, or you can create a graph from an existing source, which can be a Neptune cluster or directly from S3. Now, when you're creating and working with graphs, I mentioned earlier that you're going to be working with an amount of capacity for the workload that you're doing. So we're going to select the maximum capacity that we need for this graph. It's a small one. and 128 memory MNCU, which is a memory-optimized Neptune capacity unit. It's the same type of unit as when you're working with Neptune serverless, except this is memory-optimized. You're going to provision that, and it's a 1-to-1 ratio for the amount of GBs that we're going to provision to run your workload. So 128 here is going to spin up the amount of infrastructure for a capacity of 128 gigs. When you're looking at the data you have on disk, it's about 7/11ths the size of what you see to what you should select here. When we load up, we are going to pick the S3 read-only role. And down here, we're going to load directly from S3. Now, we're working in US East 2. And then lastly, when you are creating a graph, you do have the ability to set some different availability requirements, like how many warm graphs that you would like to have standing by in case of a failover if you're running live traffic. Oh, thank you. We had someone catch a demo bug. I really appreciate that.
Sounds like someone who's found that one before.
Absolutely. Thank you. So for this graph, this is just a demo, so I don't need any warm graphs that are going to be standing on the side. And then lastly, here is one of our customers' most favorite aspects of working with this. When you create a graph, if you would like for the security requirements of where you're at, you can make it straight to be accessible from public.
I mean, who here has used Neptune and wish they could do it from their local machine? I know I have.
Yeah. So what this is going to do is when we create our graph, it's going to create an endpoint that'll be publicly accessible. I'm going to copy that and put it right into my Jupyter notebook, wire up that Jupyter notebook, and then we're going to be good to go. And then lastly, vectors. We're going to go ahead and make a vector search index for this graph. The data set that we're loading in is a knowledge graph that has embeddings trained from Hugging Face on the nodes that represent investors. Those embeddings have a dimension of 384. So we're making a vector search index here in my graph of dimension 384. And I'm going to turn off delete protection so that I can turn this off when we are done. And let's go ahead and create our graph.
Living dangerously.
I'm sorry?
Living dangerously.
Living dangerously, of course, always. So I have this one up from earlier just to give you guys a glimpse of what it would look like when you have your graph created. When you have your graph, this is where you can find the ARN and you can get your endpoint, your publicly accessible endpoint, so that you can work with it in notebooks. And I think that one's going to take a moment to bake, so I have one up and we're going to use that for the demo. What I'd like to also show you is all of the training material that team members like Dave have worked tirelessly to create so that we can help teach the power of graph algorithms and working with graphs if you are interested in learning about them. So when you fire up your notebooks, you're going to have a canned set of Jupyter notebooks that are going to teach you how to apply graph algorithms to specific business problems. That's where we are, so we're going to go into Neptune, and you're going to see Neptune Analytics. And in Neptune Analytics, you're going to see a whole series of getting started Jupyter notebooks like graph algorithms, where you can go through and understand what is a pathfinding algorithm? How do I apply it to a business problem? What are community detection, centrality detection? We've got notebooks that we've set up so you can walk through and teach and learn how to use them. For this demo, we are going to go into Neptune Analytics, the sample use cases, and we're going to do some investment analysis here. Now, this data set, just to give you an idea of what we are studying in this demo, this data set came from the Edgar data, and the Edgar data collects holders or collects investors and the investments that they invested in during a quarter. This data comes from any investor that holds over 100 million in investments in a quarter, and then they must file, and this is publicly available data. So we have just loaded that into this graph, and let's take a look at the data model that we're using so you can have an idea of what types of relationships are very important for this data set. On the far left, you see here that we have a holder that represents an investor, like Raymond James, that you're going to see here quickly. Raymond James has so many investments in a quarter. The data that we just loaded up was Q4 of 2023. And then we also have all of the holdings or the investments that we made. So we went from one out to many investments. Using a graph is very valuable when you start to find these relationships, and the number of edges or the number of joins that it would take to do this in a relational database is when that gets very large, that's when it's a great idea to put it in a graph. The first thing that we are going to do here is make sure that we have our notebook set up and that we have our graph endpoint. So whenever you are doing this on your own, you can see here on this cell, I dropped the endpoint of my graph, and all I need to do is use the notebook magics here to change the graph notebook host to that public endpoint that we just created, and then your notebook is going to be ready to start practicing graph queries, graph algorithms, and vector search together. We've already loaded the data, so please pardon one more scroll here. And we're going to start with this first query. The first query that we would like to do on this data is we just loaded up an entire quarter's worth of SEC filings for this data of anyone in that quarter who had over 100 million of investments. And what do we want to know? We want to know who are the top 10. So what we're doing in this query is we're going to match, and we're going to do a graph query looking for an investor through that quarter and then all of their investments that they had, and we're going to sum them up and return them as a ranked list. A very analytical style query that you would want to do with a graph. And you can see here that, as I mentioned and gave you all a preview earlier, Raymond James is our top investor for the quarter in this data set. One of the next things that you might want to do when you are working with a graph in Amazon Neptune Analytics is you might want to combine running queries together with one of our graph algorithms that we have natively deployed in this engine. And most often, one of the questions you would be interested in asking is, well, how are the competitors doing compared to, Raymond James or the top other portfolios? And we're going to use a graph algorithm called Jacquard similarity to do that. We're going to start with finding the top 10 investors who had the most holdings in that quarter. And we're going to find all of their competitors. We're going to use a graph algorithm called Jacquard similarity that's going to look at the differences between the top 10 and then all of their competitors. If you are curious about the details of Jacquard similarity, we've got some great information, including here how to interpret the analytical result. When you run something like Jacquard similarity, higher score is better, meaning that they're more similar. What this is doing right here is this is starting off with an open cipher query where we're looking for first the top 10, and then we're finding all of their competitors. Now we have that list of vertices, and we're going to run an algorithm called Jacquard similarity. So you can see here when you're using the Neptune Analytics engine, you can call directly into running our graph algorithms that we've implemented natively in that engine. And that's giving you the ability to take a look at the top most profitable investor from this quarter and then directly compare them to their competitors. The really interesting part about this that we just saw is that this is an analytics engine that is allowing you to combine queries and algorithm workloads back to back and being able to mix them together. It's something, David, I think you told me that our customers have been most interested about so far, being able to bring those together.
Absolutely. It's really being able to combine together the power of OpenCipher with the power of these algorithms in a way that you can really kind of compose these very complex questions into relatively simple and straightforward query syntax is somewhere that we've definitely taught. Many of our customers really, really liked and really think it's really one of the very most powerful areas of Neptune Analytics.
Yeah, absolutely. Because customers before were having to write many data pipelines, spin up custom jobs just to run an algorithm and then combine it back with what was in the database. There is durability behind this, so you can take a snapshot and store wherever you are in your process and then load that snapshot back up whenever you're ready. And the ability to kind of work with these workflows and is giving our customers an overall lower total cost for bringing graph analytics into their stack. And so the last piece I would like to show you here is one other way to do similarity when you're using Amazon Neptune Analytics. So we just used a graph algorithm to do similarity. We use the Jacquard algorithm. It's a very popular algorithm. Another way we can do similarity with Neptune Analytics is by using our vector search index. We've stored embeddings when we did the data load on those investors. And what we can do now is find those top investors, and we're going to skip that process, and we're going to call our vector search index here, and we're going to find the top N by using our vector similarity search engine in Amazon Neptune Analytics. That engine is happening right here. We're also going to be using, like you saw before with the algorithms, we're using that call step so that you can use that vector search in the middle of a graph analytic query. so that you can be combining together a graph traversal with vector search to make your results much more explainable. That's why our customers have been loving Amazon Neptune Analytics so far. So with that, I wanted to make sure that we saw how to create a graph, how to load your data directly from S3. I wanted to make sure that you guys knew how insanely fast this engine was, so hopefully you got to see that. And then I also wanted to give you an idea of how to run algorithms and vector similarity search in Amazon Neptune Analytics. So I hope you guys learned something and enjoyed the session today.
Yeah, and thank you all for coming, and we really appreciate your time here. And here at Amazon, I'm sure you've been asked a million times, but please fill out the survey. Hopefully we earned high marks from you, and we're really glad that you were able to spend time here at the end of the day with us.
Thank you, Denise. Thank you, Dave. If you have a question for them in just a few moments, give them a few moments. They can be at the back of the theater and take any questions that you have. Thank you for the presentation. Thank you for joining. Thank you for coming to reInvent. Have a good night.